Welcome to Module 6, Lesson 22, Area Problems with Circular Regions. Okay, so you guys learned how to calculate the area of circles previously in grade 7. Okay, it was some time ago. I'm going to have you now apply this knowledge in order to calculate the area of composite shapes. Okay, so throughout this lesson, that's what we'll be doing. The problems become progressively more challenging, okay? So it's very, very important that you have the necessary knowledge and skills for every one of these problems. So we'll go ahead and we'll talk about these as we go along. So the first problem is this one right here, okay? And it says the circle to the right has a diameter of 12 centimeters. Okay? Calculate the area of the shaded region. Okay? So I have been instructed here via my instructions is to allow you to struggle through this question. Okay? So you may not have to struggle, but you may. So what I really, really want you to do, and I'm counting on you doing it, is go ahead and pause and do what you need to do to figure out or to calculate the area of the shaded region. Okay? And come on back and we'll go over it step by step. Okay, so I hope you did allow yourself to struggle a bit with this one. Again, I know struggling is not something we like doing, but through the struggle, you do indeed become a lot stronger, and I think it does apply here with math, in that the struggle can indeed open up some insights. Okay, let's go ahead and let's start this right now. So what we are told, what we need actually is we need the radius. Okay, we are trying to calculate the area of the shaded region, and that shaded region happens to be part or 1/4, in fact, of a circle. Okay, a quarter circle. So we know it's a circle. Therefore, we're going to need radius. Okay, what we have been given diameter. Okay, diameter was 12 centimeters. Okay, therefore we know that we have a radius of 6 centimeters. Okay, and that 6 centimeters, when we're talking about radius in a circle, and that radius, of course, always naturally originates from the center point of the circle. Okay, that all of these lines are all equal. Okay, the last one's kind of crooked, but all of those lines are equal. Even these two here I'm drawing here. Okay, all equal. All those lines of radius are equal, and we'll see how that comes into play later on in the lesson. Okay, but yeah, moving on further, then all we need is the area of a circle, which is pi times r squared, or radius squared. Okay, that applies to that entire circle. Okay, so that entire circle there, the area can be found through this formula right there. Okay, but that is not what we are looking for. Now I'm giving you my way. Now you may have, and we're going to talk about a couple of different ways that a couple of fictitious students approach this problem, but my approach is to say, hey, we are not interested in that entire thing, so let's cut to the chase. Okay, we are actually only interested in the area of the shaded region, which happens to be 1/4 of the circle. Therefore, I'm going to cut right to it, and I'm going to use this formula here: 1/4 times pi times r squared, radius squared. Okay, because I want 1/4, probably I should probably do this. Okay, so I want 1/4 of that. Okay, because that, of course, is right there, but that is the area of the entire circle, but the 1/4 portion right here, multiplying it by 1/4 is going to give me just that shaded area, okay? And I better get rid of all these new strokes here. Okay, so then I go ahead and I just follow through with it, all right? I have 1/4 times 3.14. I'm using the actual rounded value for pi here. Later on in this lesson, you will see that you will be asked to just answer in terms of pi, where you're not actually applying any value to pi, just leaving it alone. Okay, but here I am going to actually find a true amount here. So I have 1/4, okay, because that 1/4 applies to the fact that I'm only interested in a quarter of this circle, this region right here, 1/4 of that circle. 3.14 is my pi, and then 36 is my r squared, of course, because my radius is actually, if I've written that down somewhere, I did before, I think, but of course, just to remind us, my radius, of course, is 6 centimeters. All right, and that's right there, 6 centimeters. So, just so I know that, and that is 6 squared. Continue, and that gives me 28.26 centimeters squared. Okay, or squared centimeters. All right. Hopefully you got that. If not, hopefully close. If you weren't close, hopefully you will be closer in the future because of this problem. Okay. Now B tells us about Sasha, Barry, and Kira, okay, and they wrote 3 different expressions for the area of the shaded region, okay, and that shaded region, of course, over here, okay, that shaded region now is in yellow there, okay, oopsie daisy, here we go. So yeah, they have different versions or different expressions for this shaded area. So I want you to go ahead and describe what each student was thinking about the problem based on their expression. Okay, so you're going to look at Sasha's expression, then Barry's expression, and Kira's expression, and what were they thinking? Okay, what were they thinking about? How did they come to use the expression that they used? And I would tell you right now that every one of their expressions is going to lead to a correct answer, okay, a correct solution, but they approached it differently. What were they all thinking? So go ahead and take a minute and just jot down some of your thoughts for Sasha, Barry, and Kira and their expressions and what you think they were doing, okay? Yeah, do that quickly and come on back. Okay, well, here we go. Let's go ahead and take a look at Sasha's first. Well, Sasha's may look very familiar to you, okay, because Sasha's happens to be mine, pretty much, okay? She gets directly to the shaded area, okay? Directly to the shaded area because she has that 1/4 times pi times 6 squared, which is radius squared, okay? That's exactly what I did. So Sasha went directly to that shaded area. Now, with Barry, okay, Barry has pi times 6 squared, okay, which is the radius, minus 3/4 pi times 6 squared, okay? And you'll notice what he's done, if you notice, he has actually finds the area of the circle first and then subtracts the unshaded portion, okay? So here's the area of the circle, okay, and that's pi times radius squared, which is that, and then he subtracts away 3/4 pi times radius squared, which to me seems very silly. Can't imagine ever doing it that way. But if you did, don't. I'm not calling you silly, but Barry should know better, right? Sheesh. Anyway, okay, here we go. And finally, Kira. Okay, Kira's was the strangest to me. Didn't really quite understand what she was doing, why she was doing it, but I thought it was probably the most convoluted process, all right? And convoluted means kind of maybe misguided, a little too confused, okay? Because what she did is she finds half of the area and then half of the half, which is the 4th, okay? So she finds half right here. Here's half of the area, okay? which would have given her, we had this here, and we're trying to find this portion, pretty much. What she's doing first is she's finding half of it. She's finding that. Well, actually, I should probably put it on the other side. She's finding that, okay? And then she's taking half of that, which is going to be that, which is what she wants, okay? But still, seems quite convoluted, too many steps. Yeah, the only one I really like, but again, if you used any of these others and got the right answer, that's fine, but is this idea right here, okay? Okie doke. All right, so here's exercise 1. Exercise 1 now, we want to find the area of the shaded region of the circle to the right. So if you would go ahead and struggle with that for a little while, maybe it won't be a struggle. Use what we just saw and we just looked at and we just did to help you out, and come on back and we'll solve together. Okay, well, excuse me if I have done this part already, because I noticed, I looked up in my left-hand corner of my screen and saw that my little timer mechanism was not counting up anymore when I got to the next page. Therefore, I'm not sure if I did any of this yet. So I'm going to go ahead and solve this right now. Hopefully I didn't. Anyway, here we are. So the first thing I want to do here is I want to find the fractional portion of this circle I'm dealing with. Okay, so I have 3 pieces out of 8. Therefore, I have 3/8 of this circle that I am dealing with. Okay, so 3/8. That's what I am interested in. Okay, only 3/8 of it. And because I want to deal with 3/8 of the circle, all I have to do then is just to apply my area of a circle, which is pi times r squared, or pi times radius squared. Okay, and there is my radius right there, 12 feet. Okay, 12 feet. Therefore, I can go ahead and plug that in. Therefore, now I have, next step, I have 3/8 pi times 12 squared. Okay, continuing forward. Go ahead and apply my the actual value, or the rounded value of pi. So 3/8 times 3.14 times 144. Go ahead and do that, and I get 169.56 feet. This is a decimal point right there, 0.56 square feet. Okay, square feet. Okay, so the question now, next question here, B, asks me, or asks us, to explain how the expression you used represents the area of the shaded region. So why don't we go ahead and just do that one together here. What it does is actually just cuts right to the shaded area. Okay, it's what we did before, the same process that I used in the problem prior, and you may have done the same. Okay, because I have my 3/8. Okay, there's my 3/8 right there, and then there is my circle formula. Okay, pi times r squared. And I cut right to the chase. So the answer I get is going to naturally just be concerned, or just be this area right here, because I've accounted for that by my 3/8 right there. Okay? All right, so here's our next one. The next one is looks really fancy schmancy, but all we need to do here is calculate the area of the figure below that consists of a rectangle and 2 quarter circles, each with the same radius. Okay, now that confused me at first, because I was like, each with the same radius. Does that mean the rectangle too? But should have said both with the same radius. But anyway, here's what I mean. Yeah, and again, this answer is going to be left in terms of pi, so you don't need to apply the 3.14. Just give your answer in terms of pi, and if you forgot what that means, you'll see that in a minute. And again, the 2 quarter circles, each with the same radius. So that means that we have these 2 radius, okay, or radii, all right, are going to be the same. They're going to be equal, okay? Therefore, you can figure those out based on the other numbers that you have. Okay, so there's a little bit of problem solving to start with, before you go ahead and do your calculations. So I would like you to go ahead and struggle with that. Struggle is the word today. Struggle with that a bit and come on back and we'll check in. Okay, well, let's go ahead and see. So yeah, we have 14 inches for this entire bit here. Okay, that entire line right there, and 6 inches here. Okay, therefore we can plug in our 4 feet. Oh, sorry, I put feet. I'll change that later actually to inches. But anyway, it should be inches right there. I should change it right now, but it'll look like it's being changed again later on. So I put these strokes in earlier. Okay, mistakenly put feet before. So there we go. So now we know our radius of both of those quarter circles is 4 inches. Okay. All right. So the area of a rectangle, easy part. Now we're taking this thing apart. We're decomposing. Okay. The area of a rectangle very simply is base times height, and we have our base 6 inches right there, and the height. Ooh, what is the height? They haven't given us the height. Well, if you do remember from earlier in this lesson, I mentioned that we'd come across this again, but all of these, this line and this line, they are both lines of radius as well. Okay, they are both lines of radius. Therefore, they are both 4 inches. Again, there we go. Here I am changing it to inches. Yeah, they're 4 inches as well. So every line of radius there in those quarter circles is going to be 4 inches. So therefore, we have our area of our rectangle, which is 6 times 4, which is equals 24 square inches. Okay, and now the area of a circle. Okay, well, actually, the area of the circle, the circular part of our problem, actually, is 1/2 pi times r squared. And why 1/2? 1/2 right here. Why 1/2? Am I using 1/2? Well, the reason I'm using 1/2 is because what I have here, I have 2 quarter circles. Okay? These 2 quarter circles, when put together, are going to be a half circle. Now, if you went ahead and did 2 times, see, this also would work. You could do, I'm just going to put this over to this side real quick. So 2 times 1/4 pi times r squared. Okay, that right here is the same as this right here. Okay, this would show that I'm finding the quarter circles separately and then multiplying that by 2. But otherwise, what I've chosen to do here is actually to do them together right away, and found out that those 2 together equal 1/2 circle. So that's where I got 1/2 pi times r squared. All right? And now I go ahead and figure this out. 1/2 times 16 pi is, again, inches squared, is going to be 8 pi inches squared. Okay? Because 1/2, I'm just multiplying 1/2 times the 16, which is my 8. Okay? And yeah, so I have 8 pi inches squared. This kind of bugs me anyway, this whole, in terms of pi sometimes. It's a little bit more confusing than it needs to be, I think. Anyway, yeah, so finally, all together, this is how we would express the area altogether of this figure. Okay, would be 24 plus 8 pi inches squared. Okay, because we have this as our 24 inches squared here, and then these 2 together are 8 pi inches squared. Okay, so you'd add these, you'd add this rectangle to these 2. Okay. Yeah, and there you go. There you have it. There it is. Yeah, hopefully you got that. All right, here we go. Another little kind of a tricky one that takes a little time. Actually, these problems are some of the most fun problems for me. I know a few of you have actually expressed enjoying geometry as well. It's a real fun kind of problem solving, taking apart, putting together is a lot of fun. So anyway, well, for me and some of you. Anyway, here we go. Example 2. So example 2 says the square in this figure has a side length of 14 inches. Okay, we can see that right there, 14 inches, and it's a square. The radius of the quarter circle is 7 inches. Okay, is 7 inches, and that would be these right here. Okay, so these here are going to be 7 inches, all of those lines of radius, and there are several of them there. Okay, so here's what I want you to do is estimate the shaded area here. Just give me a quick estimate. And if we were to estimate it, I'm thinking, boy, I have 4 of these quarter circles, so that's just going to be one, okay, one hole, all right. I have this is 14, and I know it's a square, so it's 14 by 14, and I know that is what, 196 plus what's that? 49 times 3, 50 times 150, and there's like 346 or something like that. And did you hear the way I did that? I'm sorry, probably a little bit confusing. So if I say 346 centimeters squared for the whole thing, okay. I'm sorry, no, I did that wrong. I need to subtract, don't I? Yes. What did I say? The whole square was about 196. Actually, it is 196. And then the estimate of the circle, that one circle, which is a product of these 4 quarter circles. What did I say it was? 100 and I said so 7 times 7 is 49 because that's radius squared times 3, which is about 50 times 150, right? Yeah, so I'm going to estimate about 46 square inches. Okay, that's what I would estimate. I'm sorry, I did that for you. I should have had you just go ahead and do that yourself, but I hope you understand what I just did, okay? But that's my estimate, all right? Now we're going to go ahead and calculate, okay? What is the exact area? So what did I say that was? I said 46 was my estimate. Let's see how close I do come. 46 square inches. All right. Okay, so if I go ahead and look at that, and again, one hole right there, okay? And so area of a circle equals pi times r squared. And since I know this is one whole circle, that's going to be 3.14 times 7 squared, which gives me 153.86, which is very close because I had estimated, 150, right? And then I have a square, therefore it's 14 times 14, and that equals 196 square inches. And that is all of that entire part. Then I'm going to subtract away the circle, and I will be left with the green bit. Okay, that green bit right there, which is 42.14 square inches. Okay, which is pretty darn close to my estimate of 46 square inches. Okay, so I'm pretty proud of myself, and hopefully you are as well, of me. No, or hopefully you did it yourself. I'm sorry, I never told you to pause or anything, but hopefully that made some sense to you. I'm sure you'll see more of these in your problem sets for you to work on and get enough practice with. You know, I didn't do this one here, but down here it says, what is the approximate area using pi is 22.7. So if I go ahead and do that, again, I think what they want you to do is use fractional values, okay, not to lose our skill in doing that, okay. So why don't you go ahead and do that. Here's my value with using 3.14 as pi, but why don't you go ahead and find the approximate area using 22 sevenths as pi, okay, because 22 sevenths is very, very close, as you know, to 3.14 as far as a fractional value is concerned, okay. All right, so go ahead and do that and come on back and see what you get, and I'll do it as well. Okay, so let's go ahead and take a look at this. We know our square is going to be the same, okay, 196 inches squared, because it does not require the use of pi in calculating area, okay. But if we go ahead and use 22 over 7, instead of 3.14. It would be 22 over 7 times 49 over 1. That 49 over 1, of course, is my 7 squared here. Okay, same as that. And then if I do my cross cancellation right there, I get 7 and 1, and then I have 154 over 1, which is the same as 154 square inches, and then I would have 42 square inches. Okay, and you can see how very insignificantly different that is. Okay, I mean, we're talking square inches. I mean, if you're talking square microns or something like that, it might be not so small a value. Anywho, yeah, there's that. Okay, and hopefully you reached that yourself. If you didn't remember how to do all that, I hope that that helped, because again, I'm sure you're going to see this in your problem sets. Okay, and here's exercise 3. Exercise 3 says the vertices A and B of rectangle ABCD are centers of circles, each with a radius of 5 inches. Okay, so find the exact area of the shaded region. Okay, find the exact area of the shaded region. I'd like you to mull that over, struggle with that for a little bit before attempting it, and come on back and we'll check in. Okay, well let's go ahead and get to this here. All right, let's just mark down what we know. And here's what we know, just based on what they gave us. Okay, we have each of those circles has a radius of 5 inches. Okay, so we have 5 inches here, 5 inches here, and we know this is going to be 5 inches here because it is also a line of radius. Again, do not forget that very, very valuable piece of information. Okay, so those are also going to be 5. And therefore, we know that side of that rectangle is 10 inches because it is just 2 times 5 inches. Okay, so we have our, you can see we have our rectangle here. So what I'm going to do is I'm going to do a lot of decomposing and composing and all that kind of thing. I'm going to decompose here. I'm going to find my, my area first of my rectangle. Okay, I have that rectangle right there. I'm going to find that first. And the area of a rectangle, of course, we know is base times height. And then we have 10 times 5 because we were able to get those values based on what we knew about the radius of those two circles. Okay, so we have that. So we'll keep that to the side, 50 square inches. Now I'm going to go ahead and calculate or come up with the area of those two quarter circles. And remember, those two quarter circles, just like we saw before, are the same as 1/2 circle. Okay, same as half a circle. Okay, and then we have area of 2 quarter circles. Okay, 2 quarter circles equals 1/2 pi times r squared. Okay, and all I have now to do is to plug in that value. I'm going to use 3.14. You could use 22 over 7 if you want. That's fine. I'm using 3.14 and times 25. Of course, 25 is my r squared. Okay, I'm just cutting to the chase here a lot. Okay, but I'll keep reminding you of what I'm doing. All right, and then that gets me to 1/2 times 3.14 times 25 gets me to 39.25 or 39.25 inches squared. Okay, and that is going to be the bit there inside. So we take the whole rectangle, which is 50, and subtract away those 2 quarter circles, and we get 10.75 square inches, or 10 3/4 inches squared is the value of that pink shaded area. Okay. Alrighty, so here we go. Find the approximate area using 22 over 7. Okay, 22 over 7. Well, let's go ahead and do that. Why don't you, if you didn't do it already, do it now. Okay, so the rectangle is going to start out as 50 square inches, going to stay the same. Okay, but then again, now having to figure out the value of the half circle, okay, which is the 2 quarter circles. Okay, do something like that. I get something like that, and that, and that. Okay, and I know I could have done a different way here. I could have actually could have divided this here by 2 at some point here. Okay, I could have just divided it by 2 and gotten that figure in sevenths instead of 14ths, and so I wouldn't have had to have actually done this here, reducing or simplifying. Okay, anyway, 50 minus 39 2/7 equals 10 and 5/7. All right, and you can see that they are different. You know, we had 10 and well, the other one was like 10 and 3/4, right? 10.75 square inches. We are working the square inches still, right? Yeah, inches squared. Okay. This was the one before when I used 3.14. I got 10 and 3/4 or 10.75 inches squared, and here I got 10 and 5/7. Okay, they're close, probably close enough. All right. Now it says find the area to the nearest hundredth using the pi key on your calculator. Okay, I'm not going to necessarily have you do that. If you go ahead and do it, that's fine. I'm going to just go ahead and skip over that one. It'd be interesting, and maybe I'll do it later, but I'm not quite interested in that right now. Okay, but you should get used to that pi key if it makes life easier for you, because it can. Okay. All right, here we go. Next, we have the diameter of the circle is 12 inches. Okay, now just pay really good attention to that diameter of the circle. Okay. Now, you're not going to solve this here, but you are going to, what I want you to do is go ahead and write and explain a numerical expression that represents the area of the shaded region. Okay, write and explain a numerical expression. So again, I want you to struggle with this. Look at this closely. Come on back and we'll do it together. Okay, so welcome back. Let's go ahead and go through this here. All right. So again, we're going to write and explain a numerical expression. Okay, so firstly, what we know is the area of the shaded area is going to equal the area of the quarter circle minus the area of the triangle. And you may or may not have seen that. It looked like a really, really funky shape, huh? But the truth is, it is very simply a subtraction problem, the quarter circle minus the triangle within. Okay? All right, let's see step number 2 here. Okay, so the diameter of the circle is 12 inches. And again, to pay really close attention to the fact that we were talking diameter. Therefore, that diameter there was 12 inches. So each line of radius is going to be 6 inches. Okay, and all of them are the same. All right, as we have mentioned time and time again. Okay, so we know both the base and the height of that triangle. So we have the base and the height of the triangle. We have the radius of the quarter circle, and we are set. Next step, so shaded area of a quarter, pi times 6 squared. That is our quarter circle. 1/4 of pi times 6 squared, which is the radius squared. And subtract away 1/2. 6 times 6, because the area of that triangle is going to be 1/2 base times height. And all of that inside of those larger brackets there, or parentheses, is going to be in inches squared, okay, or square inches. All right, so if we go ahead and solve here, we have 1/4 times 36 pi. Okay, we're writing an expression here, and this is why I'm not actually plugging anything in for pi, and that's really, really important. Okay, and I'm not sure if you did or didn't, or maybe you just got to that point. I mean, that point right here. I mean, this is decent as well. Okay, it is good. All right, but I'm just taking it a little bit further. down there. So I have 9 pi. So my 9 pi square inches, or 9 pi square inches, is going to be the expression for that quarter circle. And then, of course, minus 18, because 1/2 of 36 here is 18. Okay, so this right here was this, that was that, and then again I put my inches squared outside of my parentheses because it applies to that entire answer. So that would be an expression, probably the furthest we could go without actually coming up with an answer. Okay, that expression right there. But again, if you use this other expression here as your answer, that seems okay to me as well. Okay, but you see you can go a little bit further. Okay, this idea of an expression is you leave something to be plugged into. Okay, in this case we'd be plugging in for pi. Okay, and as you know throughout this lesson, it's been, you know, pi is 3.14 or pi is 22.7. Okay, so here's our lesson summary. To calculate composite figures with circular regions, identify relevant geometric areas, okay, such as, of course, rectangles or squares like we did, that are part of the figure with a circular region, okay? Determine which areas should be subtracted or added based on their position in the diagram. And then answer the question, noting if the exact or approximate area is to be found, okay? Because we do have approximates. Sometimes, as you saw, we had an estimate in one of our problems there. Okay, so again, this is a really important part of this one here is determining which areas should be subtracted or added, okay? And that's going to come into play a little bit more heavily when we move into our next lesson, lesson 23, which will be interesting. It's going to be a combination lesson, lesson 23 and 24, because they deal with the same subject matter, but it's going to mean it's probably going to end up being a pretty long lesson, simply because there are lots of problems or exercises within. Okay, so you can look forward to that, and look forward to your problem sets, etc. And good luck, as always.